morning, everyone, and welcome back to the next concepts in business digital architecture tutorial. This video is about cloudification. So, in this video, I will try to present the, the definition of cloud, the fundamentals, the ecosystem, some concept about Docker, Kubernetes, and Docker Compose, cloud architecture like APIs, SOA, etc., DevOps, automation, cloud native, and principles, etc. So let's start with introduction. So the cloud timeline, as you can see here, start from the first day we had the ability to compute. It's in 1960 with the famous big um, um, laptop or big machine called ENIAC. It was like developed by the army, the American, the U.S. Army, and it it was like very big machines of a size of a Rome actually, and in 1980 we started to have like the client server era. It's like when we start to have a machine in the center that serve other machines, um, and just after in 1990, we start to have virtualization, and um, of course, virtualization mean like we can have multiple operating systems or multiple software in the same physical hardware. And thanks to that, we tried and we started to think about something called cloud computing in 2000. And it was like a service on demand or a digital resource on demand. It was like it was very used, and it was like cheap than buying a physical device because you pay as you go. And we will look to that in details in the cloud or Docker piles. And after in 2010, we start to have cloud native era. It's about microservices, orchestration with Kubernetes, CI/CD, serverless functions, etc. And it was very high scalable and resilient. And actually, in the future, I think we'll have the same thing, but that will be very largely used because with the era of IoT and Industry 4.0, we'll have a lot of connected systems or objects. Actually, any object or anything around us will be connected either to a cloud platform or a fog or an um, edge compose to its hardware. So I think we'll keep doing this with cloud, and we'll try to develop it and make it more widely used and of course more efficient, and it will be like base of anything that like we are using right now. For example, phones, we will have more powerful phones. Maybe we will have phones with uh, 10 terabytes storage, and of course, um, to do that, you can't build like a phone with 6 inches that has like 10, mm, 10 terabytes storage. what we will use is, of course, cloud, a service. A provider will provide, of course, that service, and all what you need is a phone that connected to internet to use that amount of storage. And of course, there is a bad side for this, but okay, let's move and let's see that in details after. Okay, for the what is the cloud question, actually, the simplest way to define this concept is to say that it's a digital um, resource as a service. It's an act as a service, anything as a service, and which is like called cloud because everything is done via the wild area area network or the public internet. So the user or what they need is just connect to internet and use the service provided by the provider, like AWS, Azure, GCP for cloud, um, for Google Cloud Platform, etc. And that service can be actually anything like an operating system instance like EC2 for AWS, a storage service like EC3, a database service, function as a service, serverless service, etc. And there is four main deployment methods or models for clouds. The first one is the public cloud, where anyone can use that resource and it's not reserved for you. It's low cost and of course you have a shared infrastructure. For the private cloud, it's the same thing to public cloud, but when you um, reserve a service, it's actually dedicated to you. Or when you reserve a resource, it's um, used by one person, which is you. Because in public cloud, when you, for example, subscribe to an um a database, um, the amount of storage is shared like with any users of that service. So it can happen that sometimes you will need more times to do some calculations, or you will be run out of memory or something like that because it's shared. So you are not guaranteed to have um, the same quality of service anytime you are using that service. But in a private cloud, you um, don't own anything in your office or at your home, but that service that you subscribed to is uh, just dedicated to you and you are the only one that use it. For example, if you're subscribed to a storage service with 10 terabytes um, and you are just using, for example, 5 gigabytes, the remaining storage is still yours and it will not be used by others. And this is why private clouds is powerful because the quality of service is guaranteed for you, but of course it is very expensive if we compare it to the public clouds. Third one is hybrid cloud. Hybrid cloud is just a mix between the private and the public cloud. It's widely used by companies that are sure that they have some services that can be in public, like the quality service is not actually very important, and they had a lot of other service that need to be private. So this is why they are using that type of deployment model. And third one is multi-cloud, and this is a very important one because thanks to this model, you can avoid lock-in. So what does lock-in mean? Let's take an example. You are a company and you um, subscribe a service with a provider, for example, AWS. Next year, this provider or this company decided to increase prices, and you don't agree with that. So the solution is to move to another provider. And if you don't have that option, you are actually locked in and you cannot do anything. Either you pay more for the same service or you lost all of your data or of your services uh, that you are doing with that provider. And of course, this we don't want to do that. So this is why multi-cloud is very important because you have the flexibility to move to from a provider to another. But of course, having multi-cloud is very complex to manage, and it's still also very expensive, and you have a risk of diversification. So for the cloud fundamentals, we have a lot of the service models, but the famous ones, we have three of them, like the IaaS, infrastructure as a service, the PaaS, platform as a service, and IaaS, SaaS, like the fourth software as a service. For the infrastructure as a service, as you can see in orange, is the part managed by the provider, and in blue, it's all the um, element that you need to manage by your own. Let's take an example. In AWS, they have a service called EC2. When you create an EC2 instance, you don't actually manage the physical server or the networking or even the virtualization. All what you manage is the operating system used in that instance. For example, middlewares, data, and application that you can use there. So it's an operating system dedicated for you, and it's up to you to manage all of that. For the PaaS or the platform as a service, you manage just your application and the data of your application. Um, an example with AWS is Elastic Beanstalk. When you host your application, but you just manage it and its data. You don't manage your operating system. You don't even know what operating system you're using. And for software as a service, it's widely used and it's the most presented like model in nowadays. And there's a lot of examples. For example, with Microsoft, when you use um, Word, Excel, PowerPoint on the browser, they're actually a software as a service because you are not installing this application in your hardware, uh, and you're still using it. Like you're still using a lot of service like storage with OneDrive. You have an area to write, for example, uh, and yeah. And for another example with Google, you have Google Colab when you train your models or you write software for machine learning. Um, in Google Colab, you just open your browser write the URL and start writing code and run it, and you will get the response. You didn't install an operating system, you didn't install Python, for example, you didn't manage anything in between. You are just using that software to do what you want to do. So there is other models like PaaS for function as a service. It's a type of a serverless provided by AWS as Lambda or Azure like functions, Azure functions, and other ones like what is like we can see like X as a service is like anything as a service, like actually can be anything as a service. Like NAS is a network as a service. Um, we can have storage as a service. We can have like compute as a service, etc. So what are the major providers? For example, if you want to use a service and you want to decide like what provider, we have a lot of them. From USA, we have AWS, like the biggest one in market with 30% around that. Azure with Microsoft, GCP for Google Cloud Platform. In Europe, we have OVH, Scalaway. Um, Also, we have Alibaba in like the Chinese company, and actually there is a lot of them. And just be aware, like when you're using a service from a provider, pay attention that like this to know actually where your service is running, which region. Um, for example, in AWS, if you created a service in Central Europe and you switch the zone or the region to, for example, Virginia, you will not uh, find the same like services because you switched the zone. So service is dependent to the zone, so just pay attention to that. And I think it's the same thing for other providers. There are some providers that manage this automatically. When you subscribe a service, it's like in a specific zone or region, and if you need it in another zone, it's like just swipe up. And all of this is just for more efficiency, more scalability, and to have more fast services. So let's move to the cloud ecosystem. The first technology that is very used by a lot of companies is OpenStack. So OpenStack is a technology to build your own cloud. We talked about private clouds, and to do that, to be able to have a private cloud, you can use an OpenStack. And of course, OpenStack can be used by also or with the other technology which is VMware, and VMware is the technology that allow us to virtualize or to have a virtualized architecture. Of course, you will need a hypervisor like an intermediate or an interface between your um, physical devices and your softwares. And here is the difference between a virtual machine and a container. A virtual machine is a machine that is running um, virtually on infrastructure. Let's say like you have a device and you need to have multi operating systems in the same machine. To do that, you need an hypervisor and you can use everything like that. Like it's like think about a virtual box created by Oracle. It's platform when you can have a lot of virtual machines that is running in the same device. And the container is not like the same thing. Containers, you have one operating system that is running on one physical device. And on top of that operating system, you need to have a container running inside. For example, Docker. And thanks to that container runtime, you can have a lot of containers. Each containers can have a lot of dependencies, a lot of applications that you don't have in your operate- operating system. And this is very powerful because it can be portable, like you can build an app in your machine and put it in a container and send it to, for example, another user that doesn't have the same operating system or the same laptop in general, and he still can use the app just by installing the container runtime and building the container you send or the image you send. So Docker is like the container runtime mostly used, and we have like this workflow when you write, like the developer like write the Docker file to specify like what the container should do. When we build, we will have a Docker image, and it's a static image or a static instance of our container. And of course, we can share it by put it in a Docker registry for others. And you can use Docker run to run the container. And of course, there is um, other command to deploy your app and to monitor this app. Um, just before Kubernetes and Docker, we have Docker Compose actually that um, can used when you have a lot of different containers, an app that use different containers. For example, you have a front end, back end, and a database. So how can you put everything together? You can use Docker Compose, of course, and of course you need to install that in your PC to be able to use it. And Kubernetes is a very high level container orchestration. I think as a startup, you don't need to do that. Docker or Docker Compose is enough because Kubernetes is actually when you have a lot of containers and you want to create pods to manage everything. And it's still like a very, very high level to do that with Kubernetes. And for architecture in cloud, we have first concept which is very important is APIs, application programming interfaces. And in any companies to have a flexible architecture, you need to use that. Because APIs, like it's the interface between any service or any entities of your company. And the idea behind is very simple. Like you have a service that is running in your hardware or backend service, and you expose the service via a URL, which is the API. And this URL can be used by any user to get information. You can use get method to write information in that service. You can use post method to modify. You can use put to delete. You can use delete method, etc. And for the SOA, which is service-oriented architecture, um, We have like the monolithic architecture, a single application, single database, and we have the microservices architecture, where anything is described as a microservice, of course, thanks to APIs. And um, in SOA architecture, we have services connected via OCP or API layer, and we have a canal for to share like information or data. And of course, the API gateway is like the 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 door or the main gate to any other service. For example, in AWS, when you created a Lambda functions or even EC2 instance, you need to have an API gateway to um, get access to those services. So in DevOps, we have a concept called CI/CD or continued integration and continued development, where we try to manage the process of the pipeline between the coding phase to deployment phase. And of course, if we need to go back to for maintenance or for tests, we can do that thanks to this concept. And there is a lot of application that allow to do that. Like Jenkins is the best one to manage your CI/CD pipelines. Um, Jenkins can be also used with GitHub or GitLab for code results or Bitbucket. Can also used with Jira for tickets or use US and also with Docker for containers and other applications. We have also the concept of infrastructure as code with Terraform. Um, when you have to define your infrastructure templates, and then you have a lot of tools to execute that. And of course, AWS, the cloud provider, provide a lot of resources to provision and extra. And there is a lot of benefits to the idea of infrastructure as code. Most important one is consistency and repeatability, version control and rollback if there is any incident, automation and speed, and of course documentation as code. In cloud native principles, we have the first one, which is scalability. Scalability means like the ability to go high and to respond to more demand or more clients. And I think a lot of the AW providers um, main objective is to have that characteristic to be scalable. Because any service can start small and can go like very very high in a short amount of time. And to manage that by your own, it's very hard. So this is like why we use cloud providers services because they are more efficient and more simple to use. When you subscribe to a EC2 service, you don't manage the scalability. You are just guaranteed that if you need more storage, you need more CPUs, you need more RAMs, you need more resources, we will be able to do that and you don't manage anything. The next one is high availability. High availability depends. We often say that it's 5 9. like 99.999% of the time you are available. Um, and that depends on the quality of service you're subscribed to. High availability means like how much of time my application is available. It can't be 10%. Um, what we are looking for is to have, for now, the best one, the best like high availability you can have is 6 9, like 99.9999% of the time. And with that, you have maybe five, like um, 4 minutes not available in month, for example, or in year. So it's still like a very interesting concept to deep in your quality of service when you negotiated that because it's still like the the most important characteristic of your app. If it's not available most of the time, it can be useless actually. We have also resilience for any incident or any problem, and to can we quick fix, uh, how can we quickly fix any bugs or any uh, shutdown or any problem we find out when our application is running. And we have like also two concepts in cloud principles like cloud ready and cloud native. In cloud ready, as you can see, we have monolithic applications, and course, the difference is on the scaling, deployment, and component compliance, and also in design focus. In cloud native, um, you have like some services that are um, like centralized, and you can also have a controllized microservices. And the key benefits for that is like its elastic scalability, high resilience, and also quick and cost optimization. But cloud ready can like be limited scalability. You can have also a complex updates, underutilized resource, extra. So the example of case study, let's say like we have an ecosystem platform, and this is the architecture. You have the user that can be connected to the internet to use some services provided by our cloud, and we have a load balancer to manage the requests from the or all users. Um, this ecosystem can start, as I said, very small, and it need to be sure that when we have a lot of users, we will be able to provide the same quality of service to those users. Um, and thanks to cloud provider, we can do that actually. They provide load balancers, they provide a lot of services that can be scaled on what we need. And this is like the most important time part to think to take in consideration when we are building an application or a SaaS, a software as a service. We need to make sure that we have an architecture that is scalable, that is reversible, and this is very important because imagine you need to move from a provider to another because you are not longer agreed with those policies. If you don't manage that in before, you cannot do it when you're stuck. So this is a very important part to take in consideration. And here is like 10 takeaway concept for someone who is working in a cloud or working as a DevOps engineer. The first one is design for failure. That means like things like will break and plan for it like in advantage. And of course, the second one, as I said, is scale automatically, not manually. Make sure that your systems are automatically scalable. Third one is everything is code. That means like infrastructure should be written like software. This is very important because you are sure that you have um, the a way to rebuild everything if it goes down. Loose compliance, high cohesion for the first part. Five takeaway is like use managed services whenever possible. Security is everyone's job. It's for the tenant and for provider. Optimize for costs continuously. API are the backbone of any good architecture. Observe everything thanks to, for example, CloudWatch in AWS, use logs, etc. And think cloud native, not just cloud hosted. And this is the end of the presentation. I would like to just present um, a quick example of what a container can look like. So I have in my directory Docker Compose, Nginx load balancer, and a web application. So in my Docker Compose, you can see that I have three um, container. The first one is my database. It's a Postgre database, and I'm using it with those, for example, user and password. And the second container is a web application. I will put the context, which is this web directory that I have here. And of course, we have just a health check test to see if everything is up. And I have my own load balancer. And here is the network and volume parts. Volume is very important because when you are using the database, you know when you're starting your instance and you kill it or shut it down, everything is deleted permanently. So you need to make sure that your data is stored somewhere. So thanks to the volume part in Docker Compose, you can save that, and you can see here like the database data is stored in Vale Postgre data. So to start this, let me just show you like in web app, I have this. I have a Docker file, an application, and requirement, of course. And in Jinx, I have just a file that say what are the configurations so for my load balancer. So to start my container or my app, I just need to do Docker. Of course, I already started Docker. So Docker version to make sure. Sorry, Docker minus version dash dash version. Okay, it's very good. So Docker, I need sudo Docker compose minus compose app minus d dash dash build app, and I will start this service, and I will check if everything is going right thanks to a healthy check. And so everything is working. I need to check, I will check in, for example, cat readme to check everything is working, I just like check this URL if it's working. As you can see, we have instance and we have two instance. To add, for example, an item to this service, I can do this. Okay, and you can see here like I added the third instance. Let's see if it's good. Like here we have three instances instead of two. So everything is working correctly. And do Docker compose down to uh, shut it down, permission denied, I need sudo. There is a command that allows you to run Docker without sudo if you need to. So I shut down, and even if I shut everything down, I still have all my data stored somewhere um, in my physical device. And to look at this, I just need to cut the Docker Compose. So it's in var lib Postgres. So cd var uh, lib ls. Maybe I have Docker. No Postgres. Docker. Um, where is my app? Okay. Yes, Docker. And in you need to go to Docker. Var lib Docker permission not accorded. So I need sudo another time. Um, I can't go to Docker to see my like um, my data. But yeah, it's still your all your data is stored in Docker, and of course you can always get it if you shut down your data. So here is the Postgre files that are stored in the physical device. Of course, don't we need we need we don't need to touch that, because if we do that, everything will lost. So you can use Docker exit Postgre like with your username and password to access the data, but like to make sure that everything is here, like just check the path you created by Docker. So everything is stored in Docker, and this is very important for any instance if you manage data and you don't wanna lose everything. So this is the end of my presentation. Thank you for your attention, and see you next time. Thank you.